This is Big Ideas from the ABC.
This session is called Geeks, Freaks and Eggheads, proudly presented by iSmart. The talk is being recorded by the ABC TV program Big Ideas. It will be broadcast in the coming weeks on ABC One on Tuesdays and Wednesdays at 11 a.m. and on ABC News 24 on Saturdays and Sundays at 1 p.m. You can also go to the website abc.net.au/big ideas and you can see this and other Writers Festival sessions there online. Now, over there you'll see an empty chair. This is the pen chair and symbolises a writer who is unable to be with us, silenced because of their work. Today's empty chair represents writer Liu Xiaobao and Liu Jia. Liu Xiaobao was sentenced to 11 years imprisonment on charges of subverting state power. He was detained shortly before the publication of the petition Charter 08, which he co-wrote and was signed by a number of prominent Chinese intellectuals and writers. Charter 8 called for political reforms, including an independent judiciary, freedom of expression, association and assembly, and an end to the Communist Party's one-party rule. Liu was awarded the Nobel Peace Prize in 2010 while in detention, at which time his wife, poet Liu Jia, was placed under house arrest in order to prevent her from travelling to Norway to accept the prize on his behalf. The Brisbane Writers Festival encourages you to support the goals and objectives of PEN. As I said, this session is called Geeks, Freaks and Eggheads. I'm Paul Barclay from ABC Radio National, and I'm rather unsure which one of those I am. I also know almost nothing about science, so that alone should make this session a very interesting one. Scientists, they say, have an image problem. They're geeks in white coats who more often than not pursue esoteric research that has no relationship with the real world. Well, that's what some people say anyway. Is there any truth to this rather unkind stereotype? What is the place of science in Australia? Do we need more scientists? And what do they, or what should they contribute to society? What's the standard of scientific debate? We're going to kick around these type of questions tonight, and to do so, a couple of heavyweights, both profs. Next to me, Barry Brook, leading environmental scientist and the Sir Hubert Wilkins Chair of Climate Change at the School of Earth and Environmental Sciences and Director of Climate Science at the University of Adelaide's Environment Institute. He's also co-author of a neat little book called Why versus Why, Nuclear Power. Gives you both sides of the argument, quite thin and very good. And Barry has received a number of distinguished awards for his research. Bryan Gaensler is astronomer and an Australian Laureate Fellow and Professor of Physics in the Sydney Institute for Astronomy within the School of Physics at the University of Sydney. Bryan's a former Young Australian of the Year and is internationally recognised for his groundbreaking work on dying stars, interstellar magnets and cosmic explosions, and his latest book is called Extreme Cosmos. Will you please welcome them both? Does science have an image problem, Bryan?
I think it does. If you look at your two panellists, we're both, unfortunately, now middle-aged males. I think that...
We're not going to hold that against you.
Well, I think that science doesn't represent the diversity of the general population in terms of gender, ethnic background and age. If you walk down the corridor of my department, it's all men. Almost all men. You won't see too many Indigenous astronomers or even people from an Asian background. It tends to be white males, and so I think that it either has an image problem or a cultural problem in terms of getting people to think science is worthwhile.
It's interesting though, isn't it? I mean, scientists in the white lab coats, they're the ones performing the obscure experiments and they're seen as the beyond the pale geeks. But on the other hand, the computer nerds hanging around the Silicon Valley, they're the sort of cool nerds, aren't they? I mean, how did this come to be that computer science became sexy and white-coated experimenting scientists missed out? Any thoughts on that one, Barry?
They make lots of money. I think that helps a great deal. You get a lot of attention when you make a lot of money, and people in science who make a lot of money usually do it in medicine as well, because there's a lot of demand for applied services there. So when you're doing something esoteric like paleontology or astronomy, whatever, it's harder to get recognition, I think, and so it tends to, people don't understand quite what people do or why they do it, and so stereotypes tend to evolve, and that's where the white-coated, frizzy-haired, mad scientist idea comes about. Even if those people actually are working behind the scenes or developing ideas that ultimately are pretty fundamental to the sort of things that we enjoy in society, technology, for instance, or medicine, or other issues that ultimately contribute greatly to everyone, even if they don't understand the science.
We've got a number of, incredibly esteemed scientists in Australia, Nobel Prize-winning scientists. We have no trouble, of course, reeling off our famous sports stars. Do you think, Bryan, that Australians, by and large, could name a prominent Australian scientist?
Well, perhaps we can go to our audience later and find out. I'd like to think so. I think things have gotten a lot better in the last 20 years, both in terms of people being able to stay in Australia and make discoveries while they're in Australia, but also in getting recognition. So I'd like to think that a lot of people could either name an Australian scientist or at least say that guy who did that, even if they can't remember the name. So I think while we're a ways off from having the scientists getting ticker tape parades for publishing an important paper, I do think that overall recognition and just simply realisation that we even have scientists in Australia has come a long way in the last few years.
Do you think so, Barry?
Partially. But science, the way science is done these days, the whole scientific enterprise, I think has changed a lot from, say, the way it was done 100 years ago. And there's less opportunity to have star scientists because so much work now is done as part of large teams requiring a lot of infrastructure, a lot of people to contribute, and the sort of knowledge boundaries that we're pushing require work which is often seen more as incremental or harder for everyday people to understand. Now, back in the 19th century, I think it was Lord Kelvin said that everything that we need to discover has basically been discovered already. That obviously wasn't the case. So I don't want to fall into that trap of saying that we're not going to have these new fundamental breakthroughs, but I think there will be fewer of them, and there'll be fewer standout scientists really working alone or working in a prominent area that come to the attention of the public. And right now I think what we mostly see are people who make a medical breakthrough. So we had Ian Fraser, for instance,
yes,
and the cancer vaccine for cervical cancer. Those sort of things will grab public attention, but Bryan discovers a new mechanism for stellar collapse, or you find a new maybe something like in paleontology where you find a new missing link, as it were, between Australopithecine and Homo erectus. That might get public attention because it's relevant to us, but a lot of the stuff that scientists do fundamentally, I think, really fails to grab public attention. And one of the few areas where that might not be the case, but where it creates a whole lot of other issues, is climate change.
Well, Bryan, you're a physicist and an astronomer, so when you go to a party and someone comes up and says, Bryan, what do you do for a crust? And you tell them, what sort of response do you get?
Well, I first make a decision as to whether I want to keep talking to them or not. And if I don't gauge that there's likely to be a conversation, I begin by saying I'm a physicist, which is a great way of ending the conversation, unless they say, me too. But if I want to engage them, I say I'm an astronomer, and obviously most people have some vague interest in astronomy, and then the danger, of course, is that turns out that they have a telescope in their backyard and they go out every night and they're disappointed to know that I don't know every constellation. But I think people generally react as if, I haven't actually met a scientist before, an astronomer, and a real complete lack of understanding of what scientists do. So they say to me, do you work for a private company or the government? Or they say, do you work at, they think I stay up all night and work during the day and sleep all day. So it's not so much a misunderstanding, but I don't think anyone has a real conception, because every time there's a story on the news about science, there's the standard file shot of someone in a white lab coat with a pipette dripping something. Yeah. And if it's not something that involves dripping something to something else, there's just a blank slate in terms of what that must actually involve.
Did they ask, what's the point when you say that you're a physicist or an astronomer?
Yeah, so they say, what sort of things do you study? And I say, well, my main thing I'm working at the moment is I'm trying to understand why the universe is magnetic. And the reaction is often like, well, if you figure that out, how will that help us?
Yeah.
And there's lots of answers you can give to that. The one I would prefer to give is, it won't help us, but isn't it important that we wonder and that we try and understand? I mean, we're humans, there's more to life than just reproducing and feeding, and asking questions is part of what makes us different from other animals.
Well, this is in part the problem, isn't it? Because inquiry is of itself a good thing, scientific inquiry. However, when pure scientists engaged in pure or sort of basic research are asked to sort of justify what they do, often it's, well, as a byproduct of this work we found out about how to invent a frying pan that doesn't stick or something like that. When in fact, in a way, you shouldn't have to defend pure science on that basis, should you? But it is, as you said before, Barry, people can see the point in medical research, but often not the point in hard scientific research, pure research.
Yeah. People like to be able to relate
to something tangible.
To something tangible, that's right. And often knowledge is generated in a way that it's not immediately apparent why it would be tangible. But part of the process of science, which is often something that is not well understood, is a type of mental discipline and an approach that is applicable to lots of other things you do apart from science. And so actually having good people who understand that and are able to do research and understand the process of finding out new things, gathering evidence, understanding it, testing it, throwing away ideas, is important because that's so fundamental to a lot of things that we do in life. So actually, the university-based scientists, which both Bryan and I are, part of our role really is allowing universities to train the next generation of graduates to think critically. And thinking critically, I think, is one of the most fundamental things any science has done. That's at the core of science. And a lot of my lectures that I give are entitled in some way, Thinking Critically About something, because I think that's fundamentally important. Teaching people to think in a way that relates evidence to ideas and is able to change those over time is really important. And then it doesn't matter whether you're studying the abdominal parts of a wasp or whether you're looking at developing a cancer vaccine. It's actually the process that's really fundamental and transferable.
Yeah, Bryan, so would we be better along those lines if we had more scientists in Australia? Would we be able to more readily understand and decipher the world around us and the various challenges around us?
I think I want to back off making a statement about whether we should have more scientists, because then you need jobs for them and career trajectories, and that becomes a financial and political issue. But I think it would be good if we had more people who had a scientific training. And just let me give you two examples. The number of primary school teachers who have a science background is small. Most of them have an arts or humanities background. And so a lot of school children get the message that science is hard or it's something to be avoided at all costs. So one of my most poignant memories from 5th grade is when my teacher, who was a very good teacher otherwise, called in the gym teacher because he was the only teacher in the school that knew the formula for the area of a circle. So I think that as educators we need people who are scientifically literate. And another area is in politics. I think there's only 11 people in federal parliament that have a science degree. And that's pretty disappointing, given the large number of people in federal parliament, that when parliament are legislating things on a carbon tax or on mining or on genetically modified foods, that there's a microscopic number of people in there who even have a basic understanding of what the fundamental scientific issues are.
We will come to that. That's an important part of this discussion, actually. But just in terms of your undergraduate astronomy and physics students, and there must be hundreds of them, I suppose, they're not all going to become clearly astronomers. What does an astronomy graduate do if he or she does not become an astronomer?
So you make a really good point. And when I have a new student who says, I'd like to do a PhD with you, I ask them a lot of questions, but the main question I ask them is, why do you want to do this? And if they say, because I want to be an astronomer, even though that's actually the answer I would have given, I say that's not the right answer, because there's only enough jobs in Australia and overseas for perhaps a third or a quarter of graduates, and you have to go in thinking that this might not be the outcome. So what I think, the reason why people should study astronomy or statistics or geology or whatever is because it teaches you how to think. Many of my graduates work in finance or medicine or law. Some of them work in science that's not astronomy, and some of them are astronomers. But astronomy is basically like a crossword puzzle with no clues. I mean, all you get is a few photons from some object thousands of light years away, and yet we're able to work out how heavy these things are, how hot, how distant they are, what's going to happen to them later. And so it teaches you how to solve problems with very little information, and that turns out to be a very important problem in trading on stocks or on dealing with complex legal questions and a whole range of other problems. So I'd like to think that our students come out just knowing how to think in an unbiased, intelligent way about difficult but important problems.
See, it's interesting, isn't it? We don't often think about science as being a good preparation for a profession outside of science, do we, Barry? But maybe we should be thinking more about that.
Yeah, that's definitely the way scientists think about it. We think about it as a method, and it's a method of acquiring knowledge, a well-proven method. So we very much think of it in terms of transferability, and so people might ask why me as a biologist would write a book about nuclear power. I'm not the obvious person to do that necessarily, but in fact I'm not really a biologist. I do biology, I have done geology and paleontology, I do computer modelling, I try and understand systems, the way they operate, and once you understand the way complex systems with feedbacks operate, which you need to do for climate change, in fact a lot of other science becomes intelligible, and often breakthroughs are made in science because scientists from one area transfer their methods or their ideas to another area where it's pretty pedestrian in their field, but quite new in the other field. And so I think that concept of transferability and having an approach rather than just a store of knowledge, that's all you've got, and that's what takes you through your job. That's what makes science quite a bit different to other professions. Even something like law, you basically learn the torts, you understand all of the history of the cases and so on, the precedents and so on. But once you know that, you've still got to, you can prosecute it on the basis of that knowledge. With science, you're generating that new knowledge yourself, and so the way you take that and prosecute it is probably different to the way a lot of people in the everyday world think about it.
Well, I mean, I'm a journalist and we like to think of ourselves as critical thinkers. We get, from my experience, very, very few graduates who come into journalism with, say, a science journalism major. Heaps of people with a literature journalism major, a politics journalism major, your classic humanities. Yet it seems to me, be a terrific fit, actually, for journalism. This is notwithstanding the ABC's science department, which is a splendid division that has got scientifically trained journalists, but they're thin on the ground. I mean, is this part of the problem that we have, that we're just not getting the word out enough, that these are really handy skills to have in the workplace generally?
There's a reverse problem as well, in that most science graduate students I have are really, really, really bad writers. And I would like them to have more literary training and be taught how to write, be taught how to construct a plot. Because when you're writing a scientific paper, you're actually constructing a plot and a story around this idea and so on. So
lots of numbers.
We need more feedback between the humanities and sciences, clearly, because I think too many people in the everyday world just don't think about maths, and they don't think about evidence and data. And too many people in the scientific world don't think about writing and grammatical construction and communicating a message. And so we have these problems both ways. We
have this false dichotomy, in a sense. Arthur Koestler wrote about it in The Sleepwalkers. Centuries ago, we artificially divided up the world into science and humanities. I mean, science used to be called natural philosophy. Philosophy now fits in the humanities, and science is now. But historically, it was never like that, was it? Those divisions were never so neat.
And look, some famous artists were scientists, such as Da Vinci. There were architects. Architecture was considered this transition field between science and art as well, because it had real elements of engineering and elaboration and design and so on. Historically, it hasn't necessarily had this division. It seems as we've moved into more and more specialised fields of knowledge, higher levels of expertise, but narrow specialisations, we've tended to have this disconnect between arts and science and the modes of thinking between those two. And I think that's unfortunate and probably not sustainable, and we need to have more of a reconnection between those two.
Look, talking about the media, as I got onto a moment ago, what do you think about the general coverage of science on television and radio, Bryan? How well are we doing in that regard?
Yeah, well, it's a mixed bag. I think on the one hand, there's a lot more science stories in the media than there used to be, and particularly a lot of stuff that isn't just copied off the wires, but many newspapers have a science, or radio, TV have a science reporter, and that's a good thing. But the ability of the medium to convey what the science is really about is it's frustrating to a scientist, particularly when you know something about the story and you know how clever or insightful the real breakthrough was, and the story you see on TV or read about in the paper is this dumbed down version of it, or it's some sideline issue which really isn't the real story. And we have debates about this a lot because a lot of astronomy is a good story for any journalist. Astronomers discovered a planet made of diamond a few weeks ago, and that was obviously good press. We have debates about this as to whether any publicity is good publicity. I actually think it is, even if the actual details of the story aren't quite correct, because it gets across to the public that their tax dollars are going into exciting discoveries. And I don't think it really matters to the public that, okay, it wasn't actually a diamond planet, it's the core of a star, and the outer layers of the star have been ripped off and just the core's left and it's about the size of a planet. I mean, that's sort of, it's important to an astronomer, it's sort of boring to a member of the public. So I actually think that even though the science, it frustrates me as a scientist, as a member of the public, I'm just thrilled that science stories are out there, and that particularly that Australian scientists are highlighted in a positive way, and that the kids who might be interested in science are seeing stories saying, maybe this could be you too. Because I really feel as a child who wanted to be a scientist, I really lacked that. My role models were people like Carl Sagan. They weren't Australian scientists. I ended up being a scientist anyway, but I think that it can't be anything but a good thing if we have stories and names and discoveries that can inspire the next generation.
And what about the popular science programs, your Mythbusters, someone like Dr. Karl Krushenitsky? They're performing a valuable function? They're popularising science? Sometimes you see some scientists looking down their nose at the way it's popularised as well.
Yeah, scientists can often be their own worst enemy. There's almost a culture in science that if you talk to the media about science, then somehow you're reducing the quality of that science, you're degrading it, or you're denigrating your quality. And of course there are traps. I mean, I remember once I was interviewed about the effect of the ozone hole on global temperatures, and I was explaining to the journalist about how the ozone hole enhances the Antarctic polar vortex, and that can block winds from coming down south to Antarctica, so it can cause cooling in Antarctica, even though we should be seeing warming and so on. But it ended up getting published as something like there's a hole in the atmosphere and all the hot air comes out. And that got attributed to me. And so I cringed, but then just shrugged my shoulders and thought, well, that's just part and parcel of dealing with it. But that tends to put off a lot of scientists. They would be horrified if that had got reported against their name. They'd be embarrassed and they'd never do it again. And scientists have to accept that the journalist is imperfect, but the scientist as a communicator is imperfect, and really you've got to try and find some compromise. Because I agree with Bryan that we need to get more stories out there, excite people about science, excite journalists about science as well. That's the way you're going to get people more scientific literate. If they find it all boring or unintelligible, they're not going to try and learn more about it. And that's what we're lamenting, I think, is that the general public seems to be becoming increasingly unscientific in the way they judge issues, and I would rather it should have been the other way around.
Well, look, a lot of journalists and people who work in the media are, apart from not having a science background, are taught, as I have been taught, to be balanced and fair in our coverage, to represent all sides of a debate. The ABC in particular, it's part of the charter, essentially, for us to do that. How do we reconcile this pluralist idea with the fact that there is good science and there is bad science? Often journalists are not trained to be able to tell the difference. And I suppose to give a specific example, we have someone like Lord Monckton who comes out to Australia. How much airtime do you give to somebody like that?
It depends whether you're the political reporter or the science reporter. Obviously, what he's got to say has an influence on politics because we're debating a carbon price, but it's not a science story. You see, in science we have this process of taking evidence and weighing evidence and judging the relative validity of a theory, for instance, on the basis of how well it is supported. Journalists could really do the same thing. They could look at the amount of evidence behind a given story and weight their reporting of that accordingly. But of course, that's often a bit boring and not controversial, and it's hard to drum up enthusiasm. And so everybody loves the debate, even when the debate is highly unbalanced. And the classic case you've got is with climate science right now, where there are always debates in science, and the debates in climate science itself are being incredibly amplified now in the mind of the public, but at the same time being misperceived as, because there is inherent uncertainty in climate science, and there is debate about mechanisms and feedbacks and sensitivities, that somehow that means the whole thing is such a mishmash that no one knows what the hell's going on. Well, in fact, if you peered down to any particular scientific discipline, you'd find the same sort of debates and uncertainties, and the public is just totally unaware of these. But it still doesn't stop the process of science moving forward and the process of a consensus emerging. It's not something that's imposed, it's something that comes out of the fact that a lot of evidence is behind us, it's very hard to dispute. Very few people would dispute the Big Bang these days because you've got this compelling evidence for it, and yet no one can really conceive of it or believe it. And so when people talk about how do you prove that carbon dioxide is causing climate change, for instance, well, you can't. Obviously you can't, because there are so many factors to consider. But you can have a huge amount of evidence to support it, just like with the Big Bang. And I won't steal Brian's thunder, but you can't prove that the universe was reduced to some infinitesimal point at some point in the distant past, but there's a lot of evidence to suggest it was.
Yeah, I mean, it's almost like the media, Brian, is waiting for the killer evidence on climate change. It's like they're waiting for, we're just waiting for that one bit of information that seals the debate. And until then, there are these two contesting viewpoints. And that's, in a sense, I suppose, the weakness of the media. That's how journalists are taught to cover stories. Do you think that means that a subject like climate change is not done justice through the news media?
I think it's probably actually a bit unfair to say it's a weakness of the media. It's a weakness of the human brain, in that we're driven to simplify things and to reduce them to simple concepts. And much of mathematics and physics is all about trying to look for some simple underlying theorem to explain very complex behaviour. But one thing the human brain and the media aren't designed to do is to get across the idea that some things are really complicated and there aren't easy answers. And whenever you deal with something like meteorology or climate change, there is no simple answer. And shades of grey is never a story anyone wants to tell, and it's something that no one really wants to hear.
Well, Tony Abbott, of course, famously said recently, when he was defending his position on climate change, that carbon was weightless. A factual inaccuracy. Do you despair when you hear, particularly in the midst of an important debate, something like that by the alternative Prime Minister being thrown into the discussion?
Well, of course, carbon is weightless if you put it in outer space, so maybe that's what he was talking about. The other argument you could have is that if it's weightless, then you wouldn't worry about a tax per tonne of carbon because it'd still be zero. But it'd still have mass. It would still have to be per mass of carbon. Yeah, you do despair when you hear that. But then again, someone who's constantly getting a microphone shoved under their mouth to make a comment about things, you can also have sympathy that they'll say silly things. As long as he doesn't repeat that, then fair enough. Everyone makes blunders like that. I'm not trying to defend or justify him. I'm just saying that I think politicians have to be judged on their policies rather than what they say when a microphone's shoved under their mouth. But at the same time, if the policy is based on something that where science is inconvenient and therefore the science is ignored, that's when you've got real problems. And that is what I'm actually seeing with a lot of the debate around the carbon price and carbon taxes and climate change in general, is that the considered debate on it, the debate that obviously goes on behind closed doors in the party rooms and when the policy is being developed, when that is really ignorant of the science, then you have a problem.
Well, I think it is a little unfair to single out Tony Abbott, because scientific ignorance, I think, is all around us. And in a sense, that's a problem, isn't it, Brian, when we are grasping with, such a huge challenge with, well, not just climate change, there's so many issues around at the moment. So we were talking before we came in about the coal seam gas issue, but there are plenty of others. Biotechnology, for example. How are we to make wise and informed decisions on these big issues? How are we to know which policy to support when we are so ignorant?
Well, it's much worse than the details of coal seam gas or biotech. There was a famous movie made at Harvard University. All these people graduating from Harvard University, one of the best universities in the world, many of them with science degrees, and someone was sticking a microphone in their face and saying things like, what causes the seasons, or what causes the phases of the moon, and 80% of them got the answer completely wrong. Quite recently, Cosmos magazine did the same thing in Sydney, where they asked people to draw or write down the formula for water. And only about half of people seem to know that water is H2O.
And these are people with scientific training?
These are just people on the street in Sydney.
Oh, okay.
But I would like to demand that, even though I don't expect everyone to be a scientist, I think it's reasonable to demand that people know that water is H2O. So I think that there's a fundamental problem of scientific literacy. And as I said earlier, I think it goes back to the school system, the science curriculum, the comfort level of teachers and teaching science. A lot of primary schools' science curriculum is called something like science, the environment, and technology. And the science will involve planting a seed and counting how many leaves it has each day. And there's a role for that. But I think that there are just fundamental things that you expect people to know, and there's no opportunity for them to learn them.
Is science a little bit like a legal opinion? You can find one to suit whatever argument you want to put at the time?
Yes and no. I think sometimes you have to look pretty hard. Ground zero for astronomy is creationists. Barry was saying that there's very few people who would dispute the universe is 13 billion years old. That's hopefully true in Australia, but in the United States that is not true. There's quite a large number of people who think the universe is 6,000 years old. I've had long discussions with some of my own relatives about this and not made a lot of headway. I think you can find astronomers who claim that they speak from a position of carefully weighted evidence that the universe is indeed 6,000 years old. The Creation Museum in Cincinnati has a resident astronomer who has a PhD in astronomy from a real university. So yeah, you can find someone from every side, but I think what do they call it in Who Wants to Be a Millionaire, where you ask the audience to vote and you normally go with that number? Well, I think in science that's a very good metric, that the consensus is just like the betting markets, the smart money normally goes on the winner. It's the same in science. Consensus is not always, but normally a very powerful indicator of where things are headed, even if you haven't got that absolute proof yet.
What's going on there? I had a similar conversation actually many years ago with a friend who was studying medicine at Melbourne Uni, and she said to me that they asked one day in class how many people in undergraduate medicine were creationists. Not quite in that language, but essentially that was what they were trying to get at. And it was something like a third of people in the class put up their hand. I mean, these are bright kids, people who finished in the top 1% of science high school graduates who believe in creation. And as you say, some PhD level astronomers. What on earth's going on there?
I don't know. I mean, fundamentally, I guess it's that either they haven't studied the evidence underpinning the judgment that the universe is 13.7 billion years old and that life on Earth was first emerged 3.5 billion years ago and so on. I mean, the evidence is so strong that the only way you could judge that the Earth was 6,000 years old was if you'd never studied it or you'd never looked at it. So maybe because of a particular ideological viewpoint or a disinterest. I mean, maybe you treat the human organism as just a mechanism to treat. You could potentially do that in medicine if you learn a lot by rote, but it's very hard.
Is it a belief system? Is it something about the way we as humans think that a belief system can override all of the accumulation of rational knowledge?
Oh, there's no doubt about that, but whether you can be a medical graduate and still do that is a harder thing to imagine. But certainly, people can be very fixed in their views, and I try not these days, I still fall in the trap, but I try not to debate people too much. Rather, I try to have a Socratic dialogue with them where I ask them questions and try and answer it themselves. Because when I do get trapped in debates, I get a bit emotional about it then, and you don't actually resolve anything. You actually drive people further towards their embedded position. The only way you bring people out of that is to get them to question that themselves, which is why I like the idea of a Socratic dialogue, where you're saying, well, why do you think this is the case? Or what evidence has convinced you of this? But doing that to a mass audience is also very difficult. It's really a one-to-one exercise. So convincing people who have a particular locked-in viewpoint is extremely challenging, and people tend to ignore evidence that contradicts that.
I wasn't really intending to talk about creation, but now that we're on it, and you've predicted in a sense, Bryan, that the phenomenon that we see in the US, where these debates are becoming more and more politically potent, may be going to arrive in Australia in the next decade or so. How do we cope with that? Because essentially I think the argument is that kids at school have the right to be taught alternative views of how we came to be. On the one hand, evolution, but on the other hand, they should be given an alternative explanation in the form of creation, and that should be written into school curriculums. What would you say if it came to that point in Australia?
I'd probably be introducing homeschooling for my family. But I think there's two things. Firstly, I think one of the reasons why people like things like creationism is because they're comfortable with certainty. It's like, this theory gives me certainty, and all scientists can give me a possibilities. So I think people have to develop a comfort level with the fact that uncertainty or paradigm shifts are not a bad thing. The difference, when a creationist says to me, well, it's all relative, you believe one thing, I believe another, can't we just agree to disagree? I say, well, the fundamental difference is that you very much hope your theory is right, where nothing would thrill me more if a discovery was announced tomorrow showing that the Big Bang was wrong. I'd go, oh, well, you'd have to provide pretty good evidence to convince me. But if it was good evidence, I'd go, that's awesome. There's so much we now need to understand. So scientists are excited when things change, where I think fundamentalists aren't. So I think you need to change, a lot of the education system now and 20 years ago when I was going through it, it's all about answers. It's all about, what is the answer? It's not about the journey or about the question. It's about getting the answer right. And so I think we need to move away from this mentality that it's all about just trying to there's only one answer and you just have to get to it as quickly as possible. I think the other thing is this issue of that science doesn't operate by proving anybody right. It only advances by disproving things. And so a theory is meaningless unless it makes a prediction which can be tested. If it makes no predictions, it's useless. And if it can predict anything, then it's also useless. And I think it's fine for people to believe in something and really want it to be true. Yeah. But a creationist has to be able to say, if we make this measurement and the answer is X and not Y, then I will accept that creationism is not correct. And any scientists will make that statement about their most dear theory. But people, I don't actually understand what's threatening about that. If you honestly believe it's right, then surely you're prepared to stick your neck out and at least hypothesize ways in which it might be wrong, even if you're pretty confident that's not going to be the case. But at the moment, you cannot have that conversation with an intelligent design supporter or creationist, because no matter what happens, if you go to this creation museum in Cincinnati, it's incredible. It doesn't matter what new result in biology or geology you find, there's some new clever twist that is so that's seamlessly incorporated into creationism. So you can't win, you can't have a discussion, because they'll always adjust the story to make sure it matches the answer they want.
If you appeal to the supernatural, then it's no longer science, because you can wave your magic wand and make it happen. And really that was what we did before we had science. We had to have explanations for how the world worked, and because it was incomprehensible, and the explanations were supernatural, and they became dogma, and they became accepted thinking. It's where science is different, in that it's a process of I like to call science a process of narrowing uncertainty, of closing those uncertainty bounds. We never get to the point where we find the answer, but we know what isn't true in an evolving fashion over time. Whereas for something like dogma and supernatural explanations, you have the truth, and the mechanism is because that's the way it is. That's why intelligent design shouldn't be taught in school, because it's not a science. You can teach it if you want in religious classes, but it doesn't follow any of the processes that any other science follows, and therefore it has no place being taught in a science classroom.
I suppose it's worth reminding ourselves of the rigorous processes undertaken in science through evidence, because so much of what we talk about and so much of the opinions that we hold across a range of things are based on our gut feeling, they're based on our experience, they're based on anecdote, they're based perhaps on a philosophical position that we all have had and maybe first formed at university. Science is unsentimental as far as all of that is concerned, isn't it? You have to be able to measure it and find it, and sometimes what you find is an inconvenient truth, if I can steal a handy line. And, you know, it doesn't quite fit into what you would want to believe and what perhaps you'd believed in the past. I don't know if you want to talk to that. It wasn't really a question, but do you think that is a problem in our community, that we're not used to testing things according to those strict processes?
Yeah, because in everyday life, people are not often called upon to do that. We just accept that things happen and work, and yet the human organism, like any organism, is developed to deal with uncertainty and to put together information from incomplete pieces. I mean, I don't know whether most people would know, but your vision is actually an illusion. It's your brain putting together an image from a whole range of pieces of information, none of which provide the complete picture. And so the 3D world that you see around you is being constructed by your brain. It's an approximation, it's a model of the real world, but it's only one way of perceiving it, and that's your brain. But people, and that's science, essentially. Science has told us that, but that's a very scientific way to look at the world as well. The fact that actually the whole world is judged on the basis of models and theories, and most people, I think, are uncomfortable with the idea of what a theory really is and what a model really is. We all are driven by models in our head of the way the world works. If we weren't driven by models, we couldn't deal with the uncertainty and complexity of the real world. We have to simplify things. And yet it's not the way people think about the way they operate in the real world, and therefore it's not the way they tend to judge problems like a scientist does. So a scientist is still a human. They still have an imperfect understanding of the way the world works. They still carry their own biases and preconceptions and so on. But to undertake the scientific process, they try and step away from that a bit and try and evaluate the world according to these models and theories that can produce predictions and test and verify or reject and so on. And that process happens in society, but happens in a very different way to the way the scientific process works.
Well, your research, say, Bryan, that gets published in a scientific journal, you spend years presumably working on a problem, you come up with something, you write it up and you submit it to a journal. For it to be published, though, several people read that, they don't know, but read your article blind in your field of scientific endeavour, the same specialty. So it undergoes rigorous checking before it's pushed out there, doesn't it?
It does. It's different in different fields. In my field, it's actually not blind, and it's normally only one referee, but I know that in other fields, it's sometimes three referees, and they don't know who you are, and you don't know who they are. I do want to push back, though, that it is a bit of a misguided story to claim that scientists are somehow these arbiters of the truth, these high priests who are infallible. If if I'm an astronomer and there's an asteroid that might hit Jupiter and create something interesting we can study, I'll do careful calculations using Kepler's laws and computers as to, work out the probabilities that it will hit, and as each day progresses, I'll refine those probabilities, okay, using the laws of physics. Okay, but the next day I'm at the grand final, my team, the siren goes and my team has a kick, and I see the kicker. Do I sit there and do the same thing? Do I say, well, based on his statistics and the wind velocity? No, I'm going, come on. And so I think scientists are all but human, and when we don't have our scientist hats on, we suffer from the same errors of judgment and misconceptions and fallacies as everybody else. And I think it's really important to realise that although we like to pretend that we live in this tower where there's theory and experiment and propositions and tests, I mean, if you look at where discoveries come from, they quite often an idea that turned out to be wrong but later turned out to be right, or there's some sort of political backstory involving someone stealing somebody else's data. One of my favourites is the chemist Kekulé, who was trying to work out the structure of benzene, and he had a dream of a snake biting its tail, and he woke up and realised that benzene was actually a ring. And so while we aspire to this, the Popper picture of theory and experiment and theories being disproved, scientists make breakthroughs through luck, through cheating, through flashes of inspiration, and sometimes by making incredible blunders. Einstein described as his greatest blunder the fact that he came up with a theory of the universe, but his theory would require the universe to expand. And he knew that couldn't possibly be the case at the time, so he introduced this fudge factor to stop the universe expanding. And 10 years later, Edwin Hubble showed the universe was expanding, and Einstein was, he could have won yet another Nobel Prize if he had just left it as it was.
Yeah.
But the irony is, of course, is that fudge factor that he introduced, that he wished he hadn't, turns out to potentially explain the current composition of the universe and the fact that the universe is actually accelerating. So mistakes and dead ends can actually turn out to be quite clever insights for other reasons later on, and it's all just part of the fact that people go with their gut, they jump to conclusions, and the scientific process is overlaid on that and irons out the wrinkles and stops the dead ends from getting out of control. But scientists are people, and they have the same limitations as everyone else. I actually encourage people who are interested to look up the 11 people in the Australian Parliament who have science degrees. I won't name them, but there are some of them that I was certainly shocked that that person is a scientist. The same mix of good people and bad, and clever and not so clever as everybody else.
Well, I mean, given that there are few Australian parliamentarians who have a science degree, and perhaps some of those who do are not great examples, great advertisements for that, do scientists themselves then, and we should point out that many of them are on the public payroll, like myself, actually, is it their responsibility then to speak out, to be publicly engaged? Tim Flannery's, I suppose, a good example of someone who is publicly engaged. Should more scientists get out of the lab, Barry?
In one way or another, yes. I mean, I don't think everyone is suited to sitting on a stage and talking to a journalist or writing a popular book or even going on a radio program and being interviewed. I mean, some people are just really bad at doing that and don't like doing it. But everyone can write a simplified summary of their work, so you could potentially write a popular article, or you could talk to a journalist intelligently and make sure that they write up something which properly conveys. You can produce a media release when you've done a new paper as a way of reaching out to journalists to say, hey, this is something interesting that you could look at. I don't think scientists often make enough effort to do that. Not everyone is going to be a Tim Flannery or someone who can get up to an audience and sell science as something interesting. But every scientist should, in some way, be able to convince people who can sell their message, at the very least, that it's something worth selling. And often scientists just neglect that part of it, and that's a real problem. And
if you do stand forward as a scientist and put yourself in the public spotlight, like Tim Flannery, there'll be a bunch of other scientists, won't there, Bryan, from the sidelines saying, oh, what's he talking about that for? He's not trained to have opinions on climate change. So it sort of cuts two ways, really, doesn't it?
Yeah, I strongly agree with Barry. I think that if you're funded by the taxpayer, as most scientists, and including myself, are, then you basically have a responsibility to get out there and be telling the public what you're doing and why it's important. And someone like Tim Flannery, I have a lot of admiration for him because, he doesn't have a PhD and hasn't published, recent papers in the areas that he's speaking out about. But I mean, it requires a lot of guts and a lot of homework to be able to get up and speak in a way that you're still speaking as a scientist, but you're not doing it through the peer-reviewed literature, you're doing it in a public stage. And I think that we need more scientists doing that. I'd be interested to know whether Tim Flannery loses sleep at night over the criticism he gets. I hope he doesn't, because he does cop a lot of criticism, but I think it's really important that we have scientists engaging in the dialogue. And they'll have the same limitations and foibles as everybody else, but they're a voice at the table that's backed by a type of life experience that's very different from some of the other voices. And I think it's crucial that we have that sort of voice in the Australian discourse.
Yeah, I think you need a thick skin if you are going to engage in those debates. I've just seen the time. We have about 5 or 6 minutes left, and I would like to encourage you to ask a question, make a comment on what you've heard so far.
Should we ask everyone before they ask their question to name an Australian scientist?
Apart from Barry, Brook and Bryan Gaensler.
How many people in the audience could confidently name a current Australian scientist? If you'd like to put up your hand.
Oh, that's pretty good. That's pretty good.
It's about half, I'd say.
Yeah, that's pretty good.
Yep.
Whenever I watch Big Bang Theory, and I have to confess I do, I just get a bit frustrated because even though I think it's a complete hoot, it just bothers me that it's basically just perpetuating such a narrow stereotype of scientists. And I just think, do you think there's a role for somebody to produce a show like that, but much more intelligent and a little bit closer to reality, but still funny? Would that be something that might help to possibly educate people more about what scientists are really like?
I love the Big Bang Theory. And I should say that I respectfully disagree with your assessment because it's not a stereotype. It's exactly spot on. I worked for a number of years at MIT, which is basically the East Coast version of Caltech, and that's exactly what it's like without the laugh tracks. So a couple of comments about the Big Bang Theory. A lot of scientists love it. They do have I believe a physicist as a consultant on the show, so all of the babble they say is actually exactly spot on. All the equations you see written down are real. It's not just making up mumbo jumbo. And I think it's a very positive story for science, because the reality, and this is a whole other forum, is that a lot of scientists are socially inept, and you could argue that a lot of scientists have Asperger's syndrome and have trouble talking to women or interacting in normal ways. And what the show says is that these are still good people and they're worth knowing. So I actually don't think the show is a stereotype or a simplification. I think it's spot on, and it shows you that scientists can be funny and have stories and highs and lows in their life in the same way that other sitcoms set around other different types of people are. So I think it's a show with nothing but positives.
You do have to be slightly unusual to be a scientist, and I've often joked with my colleagues that we think about the autism spectrum going from sort of a normal person through to someone highly autistic and Asperger's and so on. Almost anyone we could think of as our colleagues is somewhere along that spectrum. I mean, you have peculiarities that maybe you don't see in everyday life. Maybe that's what shapes being able to do science.
Well, I think you have to be obsessive to solve problems, and that sort of monomania that comes with various things on the autism spectrum. I think I certainly, when I'm stuck on a hard problem, I forget to eat and forget to shower, and those stereotypes are true. And I think that it's good that we have people like that who are prepared to do things that most people wouldn't find interesting.
So maybe we have established tonight that scientists are geeks, freaks and eggheads.
Yep. I used to really reject that tag and thought it was a very bad thing, but now I say, yeah, and it's good that we have people like that.
Embrace your inner egghead, perhaps.
I have.
And that is, unfortunately, all we have time for. The clock has beaten us. I know there were a few people with their hands up who wanted to ask a question. What I can say is that both Barry and Bryan will be downstairs with their books, signing them, so you can pop down, get your book signed and continue the discussion. We've really only skimmed the surface. But will you please thank our two guests, Barry and Bryan.
This is Big Ideas from the ABC.